Okay, so, so this is our main topic is going to be now. We're moving on to polynomials, multiplication of radicals. So still has to do with radicals and stuff. However, there's a problem from the last video, which was number 10. This should be the video 11, I believe. Anyway, what I want to do is I want to redo that last problem because I don't like how it was explained. I didn't really have the space to explain it correctly. Okay, so here we go. The topic is still radicals basically. I want to do that one last problem from radicals. Okay, so here we go. The topic that's radicals. It's good enough. And eventually it's going to turn into we're going to talk about polynomials. So bear with me for a minute. Here is that last problem. It looked like this. It was problem number 13, I believe, from the previous video. It looked like this. And now with all this room, I'll be able to explain it better, I believe. 98 x cubed y. Okay, that's the first radical, plus, so the first one had an x in it, the second one has a 5 in it, what I mean is on the left-hand side, the normal number, what I keep calling the normal number, and then inside the radical, we have 18x5, y, and we mentioned how these don't look the same at all. They're not like terms, so how in the world are we going to add these together? Well, our first responsibility is whenever you can simplify, you must simplify. So 98, we can put the perfect squares, the good stuff on the left-hand side, and the leftovers on the right. We've always been doing the same thing. This x isn't going away, so I'll put it off to the side so it doesn't mix us up. Now, what can 98 be broken down into? Remember that list of perfect squares? It went 4, followed by 9, 16, 25, 36, 49, 64. Well, 98, I didn't do the complete list. You have a complete list somewhere else, on a previous video. 98 can be split into 49 times 2 is 98. So the 2 is the leftover, 49 is the perfect square. Great. X cubed can be turned into, what's the number beneath 3 that's the greatest number that's divisible by 2? Don't forget we're dealing with squares, square roots. So x squared is the perfect square. And x, to make it up, x squared times x gets you back to x cubed. That's the leftover. Y is a born leftover because I can't get a perfect square out of it. Okay, that's on the left-hand side. Now, let's continue down the left-hand side, and then I'll deal with the right-hand side. Let's continue down here. This becomes 7, square root of 49 is 7, square root of x squared is x. The leftover is the leftover, 2xy. And the last thing I need to do is don't forget this x. This x keeps coming down. It was here, it's here, it's here. X times 7x squared, it's always multiplying each other. 7x squared, when they're next to each other, and say nothing, it's multiplying. 7x squared, 2xy. Okay, the left side is complete. Let's go down the right side, over here. I want to move it away so we have enough room. First of all, 5 is going to be with us. And then what we want to do is split it into the perfect squares on the left and the leftovers on the right. So what can we do with 18? Look at the list. 9 times 2 is 18, right? That's the greatest number beneath 18. That's a perfect square. What about x5? The number that is divisible by 2, that's the greatest number beneath 5, is 4. So put x4 with the perfect squares. What's its leftover? X. x4 times x is x5. And y is a born leftover. There's nothing that we can break it down into in terms of perfect squares. Let's keep going down here. The 5 isn't going anywhere. We'll bring it down. The square root of 9 is 3. The square root of x4 is x squared. The square root sign is now gone. We took the square root, it's gone, and that's what we want. We want to simplify as much as possible, take away as much from the radical that we can. The 2xy isn't going anywhere, they're leftovers. And now the last move over here, on the right, on the left over here, 5 times 3x squared, which is 15x squared, square root of 2xy. Can't forget the entire time that this is a plus. I could have put it here and here. It's not that important. What's really important is that I have it here on the last line. So adding. Now, do these two match now? They do. They love these type of problems on tests. They get them to match at the end after simplifying. And once they match, they're like terms. You add the two like terms together. 7x squared and 15x squared is 22. X squared, the square root of 2xy. That's the bottom line answer that you give for this problem. Okay, I don't need to waste paper. Let's keep going with this. Let me move the paper up. And at least get started with our next topic. Our next topic, and let me put it up over here. I have some room. It's the best thing for me to do is to try to keep all the room I can. Okay, what are we doing now? We are doing now section, it's R4 in your book, still review stuff from the past. And I realize you might be rusty from having not done it for a long time. Anyway, here, what are we talking about? The first thing we need to do is to talk about addition and subtraction of polynomials. Okay, so it sounds fancy, but let me show you a problem, right? It's basically getting like terms, adding like terms together. Let me show you a problem. At least we can at least get one up here, at least one. Here's the problem. What if you got, in parentheses, negative 4w3 followed by minus 5w2. So it's a nice thing in order, in descending order of the exponents. Plus 6w, that's the same thing as 6w to the 1 power, but we don't never write the 1 power. We don't need it. It's understood to be there. If nothing's there, then there's a 1 there. And then I end the parentheses. But if I take that whole big polynomial, it's a polynomial, many terms. This is 1 term, 2 term, 3 term, there's 4 terms in there. Polynomial, that's what a polynomial means. Okay, add to that 8w squared minus 4w plus 2. End of parentheses. Equals. What do? You've got to add up all like terms. Does negative 4w cubed have a like term anywhere? In the first parentheses, or they may play a trick on you. Maybe there'll be like terms in the first one, but there isn't. And there's no w cubed here either. So minus 4w cubed is going to be part of the answer. It's not going away. All right, what about minus 5w2? Now there's a match. I'm going to cross this out because we used it. Minus 5w to the second power and 8w to the second power, they match. Put them together, 8 minus 5 is 3. Keep the sign of the larger, so it's plus 3w squared. What about 6w and negative 4w? They match. That's like terms. 6w and minus 4w is 2w, so it's positive 2w. Keep the sign of the larger. Positive. 6 minus 4 is 2. Keep the sign of the larger. 6 was positive, so the answer is positive, 2w. And finally, we have a match of the constants, that's what they're sometimes called, the fancy name, of the two numbers there, 3 and 2, which is 5, and we have our final answer. That's all there is to it. Can we simplify this any further? Are there any more like terms in here? No. This problem is over. That's how you deal with a problem like this. Okay. Now, as follows. Let me bring a new page. I have some more time. So let me get another page here. There's a way for me to do this. As follows. Let me get here we go. Okay. So, sorry about that. 1 second here. There we go. And let me get another page. See if that works. There we go. Okay, so we've got another clean page here that we can continue with our topic, which is polynomials. So let me get right to it on the left-hand side. What if you have a problem like this? 7t squared I'm sorry, 7t to the fifth I meant to write. 7t to the fifth. Let me just forget that I have room. 7t to the fifth minus 3t squared. As you've seen before, there's an eraser there in the upper right-hand corner, but it takes too time to deal with. So I'd rather just cross it out and keep going. And then what if you have a minus? What if you have a minus between the two parentheses? That's what I want to discuss with you and do this problem to show you what to do. It's not going to be complicated. I think many of you already know how to do it, but still, let's not leave things unsaid. Okay, and then minus 4, end of parentheses. Okay, how do we deal with this? Well, the first move you should make, there's several ways you could do it. Let me call it problem number 2. There's several ways that you could do it, but you can do it faster, but I don't want to skip any moves. What you do is rewrite this completely. You don't need the parentheses anymore. Rewrite the first one, but this minus is going to change everybody's sign. What used to be plus is now minus. And what used to be minus is now plus. That's what the minus does. It flips the sign of everybody. So this becomes minus 2t to the 5, minus 3t to the 2, plus 5t, and plus 4. That's what the new problem turns into. This is supposed to be a plus. Sorry about that. Okay, let's look for like terms. 7t5 minus 2t5. There's like terms. 7 minus 2, the 5t5. Minus 3t squared and minus 3t squared. If they're both the same sign, add them and keep the sign. So it's minus 6t squared. This is gone. Minus 2t plus 5t, that's a plus. That's a plus. Minus 2t plus 5t is going to be 5 minus 2 is 3, and it's going to keep the sign of the largest, so it's plus 3t. And finally, these two are out. There's nothing left but that one constant. It doesn't go away. It's got to be part of the answer. But there's nothing to add it to. It doesn't have any like terms to combine with. And we're done. This problem is over. That is the answer. Okay, the next thing we need to do is to do multiplication of polynomials. We have a little more time to go. Okay, so now we're dealing with polynomials. We did addition and subtraction, and now we're dealing with multiplication of polynomials. Okay, so here we go. Here's our first question. What if you have, let's call it, I'm going to call it problem number 3, because it's polynomial still. So minus 3x cubed. Then there's this parentheses, and it's got a bunch of terms in it, really 3 terms, otherwise known as a trinomial. 4x squared minus 2x plus 6. Okay, what do? Here's what you do. You multiply this by that one single term by all 3 pieces. Multiply all 3 pieces. So what's minus 3x cubed times 4x squared? It's minus 12x to the 5. 3 plus 2 is 5. What's minus 3x cubed times minus 2x? It's positive 6 x to the 4th. And what's minus 3x cubed times 6? Minus 18 x cubed. Problem is over very quick. Got to end this video right now, and we're going to continue more multiplication.